Welcome, ladies and gentlemen, or more gentlemen, I guess, but still ladies if you are there, hey, to my fourth chapter of the tutorial on how to make a game. And this is where we left off. We got our background going on with a couple of circles laying around, some blue and some orange. So what we are missing is, first of all, life. There's nothing dynamic about this anywhere. So I would like to make these circles rotating, because I love to see them rotate. First of all, this is kind of a help thing to introduce the concept of the update function. So we got this update function going on here, and this function gets called, depending on the frame rate, a fixed number of times per second. So if you got 30 frames, it's going to be called at 30 times per second. So 1 second is while 1 second is running through, we got 30 updates. And we are using this update function to move or rotate the circles. But the circles obviously don't have an update function right now, so we give them one. We will make a public void update, and this will include rotation. And first we do public float rotation, rotation. Okay. Set that to 0, rotation to 0. And in the update function we now increment rotation. So rotation is equal to plus equal to 0.1 float. Okay. And in case this game runs really long, we don't want to get rotation so big that we could get in trouble with the maximum float, which is really high, but still. So if this is greater than this arbitrary number, which is not accidentally somehow related to pi, we set rotation back to 0. Okay, so that should be it, and easy as that. Still nothing rotates, but we get an update function. So now we have to call this update function in the actual game update function so that the circles get updated. So for each circle, C in circles player 1, we use C update, we just wrote that, done, and the same for player 2. Alright, that's it. Yeah, now the rotation value gets incremented by 0.1 per update. And what we are doing now is we are actually displaying that rotation. Remember when we used the draw function from the sprite batch, we didn't enter anything in rotation. There is the rotation thing, and there's a 0. So what we are doing is we call C rotation there, and we just do it everywhere. So we got it like that, and like that, and like that, and like that as well. So yeah, it should work. Let's try it out. And it works, even though it's ridiculously fast. Okay, we should work on that. So let's decrease the rotation by quite a lot. So let's make it really slow and see what is going. Okay, that is like really slow and too slow, I guess. Let's make it that way. Well, that's better. That's okay. Okay, so now the circles are rotating, and maybe you noticed that. I do, but I'm kind of fancy guy in that. I really love the moving detail thing. So what I would like even more is when circles actually have different rotation depending on their size. So smaller circles naturally would rotate faster, I guess, and bigger circles slower. So yeah, let's do that. So we switch the type of the circles, like we always do when we distinguish the type. We got a case 0 going on, break that, case 1 break, and case 2 break. And now we put the rotation in there. We got rotation there, rotation there, and let me see, rotation there. The 0 is, I guess it's okay. One should rotate slower, so it's like that, it's like half, and this is even, oh no, that's more, that's less, so this is even slower. So let's see, and now you see the smaller things are rotating faster than the bigger, and I really like that. It adds a lot of detail into it, and because for a phone you are working on such a small space, it's really nice to have such an easy way of putting a little bit of depth into the visual things. So yeah, let's boot up again. So we're missing, we got a lot of visuals already going on, but we're missing quite the game from the game we want to do. So I would say we first work on the unit creation, and the unit creation is a thing where you could where you could display that in a numerous ways. So most of the games display that with a number in it, the number in the circle or below the circle, or I don't know, but I really don't like numbers in that case, because you would have a large amount of numbers, and you first have to think on how high this number actually is, and I don't know. I don't really like the concept of that in that case. So what I was thinking is that I want to visually display the unit count in the circles by changing the height of the color at the circles. So if you start, let me see. Let me boot off Paint real quick. Okay, so now we got Paint up. What we can do is we make a circle here and make that blue. Blue. Okay. Okay, so what I was thinking is that if this circle is like half full, what you can see is this. And if it's like almost full, you have it like this. Or if it's almost empty, you have it like this. So this is kind of the general style I wanted to go with the whole displaying thing of units. And first of all, my thoughts on doing that were like, I can choose both the height of the image, which is the image would actually look like, I don't know. Yeah, okay. That is really annoying. Okay, so yeah, that doesn't work that well. Okay, let's make it that way. And doing it, I don't know, can I move? Stupid Paint! Can I move that? Anybody knows how? No? Okay. Okay, I don't care. So just close that. No, I don't want to change that though. For the first thing I was thinking about was I could lower the height of this thing and simultaneously lower the source height of that thing. But that would mean that the upper left corner of that image is always different. And that would be overly complex. Well, I could code something so this would work, but I choose a little bit easier method and something which is not quite ugly as well. So what I chose was I would do basically the same but inverse. So what I'm using is, I will just pause that and add a new element, and this is this blank thing, and we'll first add that for small, and this blank thing will just be laid over the circle. So we circle small blank, or cover, and then we just make it decrease the height but stay on the same level. You will see in a minute what I mean. So it's circle small cover is equal to content load texture 2D so small blank. Okay. So now what we are doing now is, after we draw the circles, we will do that right here. So after we drew the circle, we will now draw the blank and or the cover. And let me just put up on my second monitor. Where is it? Where is it? Where is it? Okay. Now what we are doing is, we take the sprite batch and we draw the circle small cover, and we'll make a new rectangle, and it will be at the same position. So it will be integer c position dot x. I can just copy paste that. I will just all copy paste that. Ha. Okay. First of all, we will change the color to white. White, and we will multiply that color value by 0. I guess 5. Okay, that will make this thing half transparent. So if you want to make something transparent, just multiply the color by a value smaller than 1, greater than 0. Let's see how this looks. Okay, you can't see anything. That is why. Let me see. 0 rotation. Okay, let's make that not transparent. Where am I? Player 1. Is that working? Obviously something isn't right here. Let's find out what it is. Color white. Oh, color white? No, that should be okay. Okay, sorry about that. The reason is obviously that I have this break here. Okay, that was kind of stupid and embarrassing, but that's just how it goes. So to fix this copy and paste thing, circle small cover, we got it here, and the cover again here, dot height, there again, and there again. Okay, now see what's happening. Okay, now you can see the covers showing up for the small circles, and as you can see, they're not. Are they fully transparent or not? What do we set it to? Okay, oh no, it's color light blue. So let's make this color white. And we got it like this, and the reason they are already transparent is because the image by itself is transparent, but I could multiply that by some values smaller than 1 and they would be even less transparent. So you can see there's a difference between these guys, but it's really small. So I'm fine with the first one, so we not make it transparent by the code at all, because it is already from the image. I could do that for everything now. I won't do it now because this takes time, and we'll do a magical jump now. So, whoop, ta-da! Now we got everything with covers up. So, yeah, now these are all covered. Of course, this is nothing which this doesn't happen at all. We still don't have anything to show the actual unit count in the circles, but we will start from that now. So first of all, we have our circles here, and these circles need to create units. So first of all, we will make a fill rate integer, fill rate, and the capacity already is there, so, and the unit count as well. So we will make the circles depending from their type, filling differently fast. So for the small circles, we will set the fill rate to, let's say, I don't know, 30, and the fill rate of that will be 20, and the fill rate of that will be, oh no, let's make that 5. Let's make that 8, and let's make that, I don't know, maybe 15. Okay, so this is kind of arbitrary, but it's just so that you can see the difference clearly. And now we want to do something during the game, so we will have to use our update function again. And what we are doing is we first using a tick which we create. So this could be private, it's an int and it's called tick, or I don't know, toc, I don't care, and tick gets incremented each time update is called. And now we can actually fill our circles. If the tick thing modulo fill rate, you should know what the modulo operator is here, then is equal to 0, then unit count plus plus. Or let us make it here, and the unit count has to be smaller or equal than the capacity, obviously, so the circuit can't get filled more than its capacity. So this will cause that every the tick gets updated every frame. So if we got 30 frames per second with a fill rate of 15, this operation becomes null twice. So this will spawn a unit twice per second. And this with the smaller values even more. So if we got 30 frames with a fill rate of 5, we get the 6 times, so 6 units per second will be filled in. Yeah, so we got our unit count already, but now still nothing visual going on to display the unit count. So now we are merging it together. So now what we're doing first is we introduce a float named percentage, and this will be, let me see, float, and we got our circle and the unit count, and divide that by the float, which is C-point capacity. So these are actually integers, and to avoid strange integer division errors, we just cast everything as a float, and we get a nice percentage out of that. So this is the percentage of the unit count in the circle. If it's full, it's 1, and if it's if the circle is empty, it's 0. So now we will, depending on that percentage, we will change the cover height. So if you imagine the cover is the gray thing, let me just bring it up again. The cover is the gray thing over this blue circle, and now what we are doing is, depending on that, we will decrease the height of that thing to make it actually make the blue thing visible. So when we think of the boundaries, if this circle is empty, the height has to be the actual height, and if the circle is full, the height has to be 0. So what we are doing is we take the height, and now, okay, the code is actually running. We take the height and subtract from that the as a float again, the percentage times the circle small cover height. Okay, so this would, okay, yeah, we have to cast everything as an integer because rectangle only accepts integers. Now it works. So what we're doing is we are taking the height and subtracting the percentage times the cover height to get the actual height. So let's look at the boundaries. If this thing is 0, then the whole right part here is 0, so we got the full height. And if this is 1, we have the height from the cover minus the height from cover, which is 0, and everything would add up to 0. But if we are using this, it will look great. Or it wouldn't, because we got the rotation still with us. Let me just take out the rotation here. 0. Okay, so we got some really strange result here, and this is because we are not changing the height of the image properly. So we're just changing the height of the destination rectangle, but not the height of the source rectangle. And we need to change that. So we copy that, and for some reason the recording screws up mouse movement, so I will do it with my keyboard. Okay, and we will put that here in the height of the source rectangle. So just to remember you, oh no, this, oh sorry, this is not the source rectangle, this here is the source rectangle. So we got a new rectangle, and this should be then again the whole other thing. So int c position dot x, int c position dot y, then the int circle small cover dot width, and now our new height thing. Okay, so let's try it again. And this time actually nothing shows. Let me see why this is the reason. Obviously you can't use for the source rectangle x and y position, it's just 0, because the image starts at 0.00 and then yeah, goes over the width and the height. So let's try it again. And now we see it fills, but quite fast actually. So let's make the fill rate even slower, double everything up, 13, 30, 16 and 10, because we are probably working with 60 frames per second right now, and this will make them increase slower. And let's crank that up even more, so we set that on now, let's set on 50, this will be 25, and this will be, yeah, I guess 10 is okay. So yeah, now you can actually see how this thing is increasing every tick until it's full. Okay, so now the same with the big guy, and whoops, just to make it a bit slower and not that fast. Maybe you didn't really caught that on the first glimpse. So the first thing we need to add is we had this source rectangle here, and we set it to null. Because we wanted the whole image. Now we don't want the whole image, but only the part we need for sitting over the actual circle. So what we are doing is we take a new rectangle and start that at 0, 0, because the image obviously starts at 0, 0 at the left top left corner. Then take the height. So as an integer, we take the circle medium cover dot width. Sorry, it's the width first, and then we do the same thing as we've done before. So the median cover minus the percentage times the circle medium cover width. Right, and we have to add a width here as well, and cast everything as integer. Integer that way and that way. Okay. Why do you know work? Integer, integer. Oh, we need 2 brackets here. And as well, we have to change the height of the destination rectangle and make it the same as we just did. So make that in brackets, minus circle medium cover times dot width. Oh, sorry, times height, minus height times percentage. Man, come on. Okay. So I just did it here with the width, and that should be the height, obviously. Sorry for that. And the height here. Okay, let's try it out. And it fills accordingly, but looks a bit strange since we left the rotation on. And yeah, I guess we can turn that off. because this doesn't really make sense. Okay, now it works. The whole thing we could just copy for the other players. I will do that now in a second. Okay, so now it should work for the other player as well. Let's take a look. And it works. The reason why this is already full is because in the level file we set this to be full, actually. Okay, so so far we have basically everything working except the actual game. We now have a fill rate for the circles, and they are moving and stuff, and now we need units and interactions, and both of them are coming in the next chapter, so stick around. And yeah, hope you have a good time, and see you in the next chapter.